Today we'll discuss about the oligosaccharides, a type of carbohydrate. The oligosaccharides are classified into three classes. This is the disaccharide, which on hydrolysis give two monosaccharide unit. The trisaccharide and hydrolysis which give three sugar unit, monosaccharide unit, and the tetrasaccharide which give four unit of monosaccharide. Now the characteristic of oligosaccharide, the oligosaccharide complex in structure and properties than monosaccharide. The second property, they are less soluble in water than monosaccharide. The third property, less sweet and less than monosaccharide. And the fourth, on hydrolysis, they give 2 to 10 monosaccharide unit. In simple word, we say 2 to 10 monosaccharide unit are found in the oligosaccharide. Now, the disaccharide, the most common oligosaccharide is disaccharide, and we define the disaccharide, the oligosaccharide, which give two monosaccharide units on hydrolysis. If we hydrolyze a disaccharide, they will give the two monosaccharide unit. The example of the oligosaccharide is sucrose. On hydrolysis, sucrose give two units, the glucose and the fructose. And sucrose is known as common table sugar. The second example is maltose. On hydrolysis, the maltose give two units of glucose, the glucose plus glucose, and this is known as malt sugar commonly. The third example is the lactose. Lactose found in milk, therefore known as milk sugar, and this is the combination of two monosaccharide units, which is glucose and galactose. The glycosidic bond are those bonds which attach to monosaccharide unit. This bond is known as glycosidic bond on glycosidic linkage. Consider this is the formula of sucrose, the structural bond glycosidic linkage formula of sucrose. Here, this is the structural formula of ring formula of glucose, and this is the ring form of fructose. This here, the group hydroxyl group are attached to sucrose, and here the hydroxyl group is attached to the glucose. These two molecules attached to one another. This carbon number 1 is anomeric carbon, and here carbon number 2 is anomeric carbon. Here the bond will form between the two anomeric carbon. In glucose, the carbon number 1 is anomeric, while in fructose, the carbon number 2 is anomeric. Now, if we remove the hydroxyl group from the fructose and hydrogen from the glucose, these two are combined with each other and form a molecule of water. Here, the oxygen remains, and the oxygen join the two molecules and form a bond which is known as glycosidic bond. But that bond is formed between the carbon number 1 and carbon number 2. This is why this is known as 1,2 glycosidic bond. Now, the sucrose is non-reducing sugar. Non-reducing sugar. How they are non-reducing sugar? Because the two anomeric carbon number 1 and carbon number 2 attached to each other. Here is no anomeric carbon on the right side. On left side there is no anomeric carbon. So there is no chances of further bonding. This is why they are not further reduced, therefore known as non-reducing sugar. If we consider the maltose is the combination of two glucose units. The glucose unit. Two glucose units combined with one another. Consider this is one glucose molecule, and here the hydroxyl group is attached, and here also the hydroxyl group is attached. If we remove the hydroxyl group from glucose first and the hydrogen from glucose second, they combine with each other and form a molecule of water. Here the oxygen remain, and the oxygen join the two glucose molecules and form the glycosidic linkage. Here the bond is formed between the anomeric and non-anomeric. The carbon number 4 is non-anomeric. So the bond formed between the anomeric carbon number 1 and non-anomeric carbon number 4. This linkage is known as 1,4 glycosidic linkage because this is formed between the carbon number 1 of first glucose molecule and carbon number 4 of second glucose molecule. Here, the one enumeric molecule, the one enumeric carbon are present on the right side, so they have chances to join another molecule of glucose. That is why this is known as reducing sugar.